Okay, so based on a question from a student, wanted to help you with the Module 3 lab activity entitled Collision Cards. And so I'm going to go ahead and share my screen. I'll try to share perhaps two screens with you. Let's see. Let me go to the actual activity here. So this is the quiz that you're going to take. And notice that the first part of the quiz, you have to open up a simulation, and then you're going to see a bunch of data here. And there's a little table, actually. And so let's see if we can draw here. So it's important that you are able to read this table. So we have, oops, I don't want a line, I want a, let's try this. There we go. In the table, you're given the mass of a red truck, the mass of a blue truck, the velocity of the red truck, and the velocity of the blue truck. These are going to be your initial settings. Okay, so let's go ahead and I'm going to take you to my other screen where we'll actually be able to show you this. So now I'm sharing my simulation screen. Now, if you recall, we wanted the mass of the red truck or cart to be 2. And so you can choose your different masses right here. So I'm going to set that to be 2. My blue truck is supposed to be 2. The velocity of my red truck is supposed to be positive 2 meters per second. And that means going to the right. And so I'm going to change this. I still want to be going to the right. I still want to be positive 2. And then the velocity of the blue, notice that right now it's set at -5. That means that the blue cart would go to the left if I hit start right now. I don't want that to happen. I want it to go at 0. So I'm going to set it to be 0. I notice one of the columns is you want the total momentum. And I tried to explain this in the video. You can calculate this before or after the collision. That doesn't matter because the total momentum is not going to change. So how would you calculate it? Well, total momentum is the momentum of everything that's going to be going on, of all the objects in the system. So to find the momentum of the red cart, I would multiply its mass, 2, times its velocity, 2, positive 2. So 2 times 2, 4, right? What about the momentum of the blue cart? Notice that it's got a mass of 2. It's got a velocity of 0, and therefore its momentum is 0. So before the collision, my total momentum, which is given as P total, P is a little t down below, is going to be 4 plus 0, otherwise known as 4. So before the collision, the total momentum of my system is 4. And now, once I've got those values set, and I may have filled in that P total, now I need to actually let the collision happen, and then I'm going to pay attention to what the velocities of each cart are afterward. So notice that I'm going to hit start. And I'm going to be very patient, allow my red cart to collide into the blue cart. Okay, they collided. Now notice that my red cart came to a stop. So again, I can calculate if I want, just to make sure that my momentum has been conserved. So let's take a look at what happened after the collision. After the collision, my red cart still has a mass of 2. It's got a velocity now of 0, right? So 2 times 0, oh, the momentum of the red cart is 0 right now. The blue cart had a mass of 2, and it's got a velocity now of 2. Well, 2 times 2, 4. So after the collision, I still wind up with a total momentum of 4. 0 plus 4 gives me a total momentum of 4. Notice that the velocities, these are the ones you need to fill out in that table. The velocity of the red cart after the collision is 0. The velocity of the blue cart after the collision, positive 2. If you put those in, you should get the proper credit. And then you just do the rest of the table in a similar manner. So let me switch you back over to, so I've already given you a couple of answers. Isn't that nice? There we go. So again, as we mentioned before, when you're filling this thing out, your total momentum in that first column was, or in that first row was 4. The velocity of the red cart afterward was 0. And the velocity of the blue cart after the collision was 2. Remember, these were elastic collisions. When you continue on through the quiz, notice there's going to be another table. In this case, the difference is you want to select the inelastic collision. Inelastic collisions for the next table. Get rid of all my drawings here. And then, like I mentioned in the video, once you filled out those tables, there's a couple of conceptual questions there at the end. But other than that, that should pretty much take care of all your all the questions on the quiz. So anyway, hope that's useful. Again, if you have problems, yeah, I'm glad that some of you are working on these extra early. If you work on them during the week, that gives you time that if you don't understand it, you can ask questions, and it also gives me time to answer those questions in a richer way. I can actually create like these videos, which I don't have quite as much ability to do at home. You know, just the facts are facts that I've got 2 screens to work with here. My internet connection is so much faster here at work. So, and plus, yeah, I've got a family. I want to do things on my weekend. So work on these quizzes early on in the week. That way you can get some of your questions answered during the week, and you won't be quite as panicked on Sunday night when you run into a simulation and you're not getting the right answers, you're getting lousy grades. I'm more than happy to give you assistance with these. So hopefully this is helpful.